the screens, because there are several options here in WebEx where you can raise your hand and all those things are there. But if you do that, I will not be able to see that. So you unmute yourself. Okay, so let us see some notations now. We are going to denote a matrix by this bold letter A. The order of the matrix is m by n. M means the number of rows, and n is the number of columns. So if Aij is the ijth element of the matrix A, then that means you can write A as A in this form: A11, A12, A1j, A1n. This is the first row. The second row is A21, A22, A2j, A2n, and so on. The last row is this mth row. Fine. And the columns are, these are the columns. This is the first column. This is the second column, and so on. Okay. So this is how a matrix is represented. And matrix has very important applications when you go to the real life situation, because you can store the information in a matrix form, and then you can use the tools from matrix algebra to analyze this information. Okay, so it is important that it is a very important topic from the practical point of view. The ith row of a matrix is written as Ri. So if you, and this letter is not bold. Okay, so if letter is bold, that means we are dealing with matrix. If the letter is not bold, that means we are dealing with a vector. So the ith row of a matrix is denoted by Ri. This is the element of the ith row: AI1, AI2, so on, Aij, and Ain. You can also write this in this column form. You take this and take the transpose of this. So this T stands for transpose. Okay, so this is Ri denotes the ith row of the matrix A. And the jth column of a matrix A is written as, is denoted by Cj, capital Cj. So elements of the jth column will be A1j, A2j, Aij, so on to Amj. And you can write this in the transpose form here, or in this form. Okay, so throughout this course, throughout this section, Ri will denote the ith row of the matrix, and Cj will denote the jth column of the matrix. And matrix itself is denoted by this bold letter. It will be either A, B, or C. Whenever you see the bold letter, that means you have a matrix there. Okay, so this is the notation for the matrix, its column and its rows. Zero matrix or the zero vector will be denoted by the bold 0. Okay, so we are using the same notation without any confusion for the zero column matrix and zero column and zero rows matrix, and as well as the zero matrix of order n cross n. Okay, so same notation is used. So bold letter 0 stands for either this or this or this one.
Question, sir.
Yes.
The screen is not updating. Like you have shared the screen, but we the screen is fixed on that the course is divided into 4-inch slide.
Oh,
The
so it
screen
is
is not
not
updating.
updating.
It's sir,
It's fine on my side.
so it's fine on my side as well.
Sir, it's
Yes,
fine.
sir, it's fine on my
Sir,
side
it's
as well.
fine.
Yes, sir, it's fine.
It's fine. Yes, sir, it's fine.
Screen is updating when I move the slide.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, it's
Yes, sir.
Sir.
Who,
okay.
who was facing this problem? Can you
Me.
can you exit and then rejoin and then see if you are able to see it or not?
Okay, sir.
Do I have any other student having the same problem? Can you see the screen when I move?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so this is so I have defined what is matrix. I have defined what is row of a matrix and column of a matrix. Zero matrix I have said, and zero vector also, column zero vector and the row zero vector. Every element of the row matrix or column matrix is zero. Okay, so now we can perform three operations on the matrix A. First operation is multiply a row by a non-zero constant. Second operation is interchange any two rows of a matrix. And the third one is add a non-zero multiplier of one row to any other row of the matrix. These are the three operations that you can perform on the row of a matrix. And the same type of operations you can perform on the column of the matrix. Okay, so we will see what do we mean by these operations one by one. So first is multiply a row by a constant, by a non-zero constant. So keep in mind that the constant that you multiply should be non-zero. It should not be zero. Okay, so with for zero, this operation is not valid. So you have simply you have simply, let us say, this matrix and you multiply this row of first row of the matrix by, let's say, some constant 2, and then you get a new row which is 4, 12, 2 and 14, and remaining, let's say, remaining rows are same. So this is multiplication of the row by a constant. Okay, the second operation is interchange two rows. That means write row I in place of row j and row j in place of row I. Okay, so let us say that I have this matrix B, and I interchange row 1 with row 2. So I do, let us say that I do this operation, interchange row 1 with row 2. So this is row 2, this is row 1, you interchange them. So first row will the second row will come in place of the first row. So you have this second row here, this come in place of the first row, and the first row will come in place of the second row. So this row will come here. Okay, so this is interchanging row 1 with row 2. Similarly, you can do this for the other rows of the matrix. Okay, and the third operation is add a non-zero multiple of one row to any other row. So if I go to this one, then after obtaining this matrix by interchanging row 1 and row 2, we get this matrix. And then what we do is we multiply multiply row 1 with a constant -2 and add this to row 2. Okay, so multiply row 1 with -2. So this is my row 1. So when you multiply this by -2, you get -2 here, -4, 2, and 2. And then add this to the second row. Add. So what do you get? -2 plus 2 will be 0. -4 plus 6 will be 2. Then 2 plus 1 will be 3. And then 2 plus 7 will be 9. Okay, so you get this row. Remaining rows will remain, rest of the rows will remain same. Okay, so this operation is multiplying a row by a non-zero constant and then adding this to the other row. So here we are multiplying row 1 with a non-zero constant -2 and adding this to row 2 to get this new matrix. Okay, so this is the third operation that we can perform on the matrix. Okay, so I think my time is also over. So we will continue this discussion in the next lecture. Okay, and I will send you the slides in a couple of hours today. The slides related to this first subsection. If you have any question, you can ask me.
Sir, I have a doubt.
Okay, sir.
Yeah.
Sir,
Yes, go on.
sir, why are these called as elementary operations? Means, are there any kind of advanced operations or what? Or means, is there any logic behind calling them elementary?
Because this is the most basic operations that you can perform. Yeah, exactly. Because you can have inverse of the matrix, you can have a square of the matrix. So all those things are a little bit. You can find the eigenvalue, you can find the eigenvectors. So these are all. They are not called advanced operations, but they are all manipulations. They are all manipulations of related to the elements of the matrix. Okay, so this is the basic thing that you can do with a matrix. It is like when you learn the real number system, the basic operations is addition, multiplication, division, and subtraction. Okay.
Okay, sir.
So without these operations, you cannot learn real number system. If you do
Sir.
not know how to add two real numbers or subtract two real numbers or divide two real numbers and maybe multiply two real numbers, then there's nothing to learn. So these are the basic operations that you have on the real line system. And similarly, for the matrix algebra, you have some basic operations. So that is why it is called basic operations, elementary operations.
Okay, thank you, sir.
Excuse me, sir.
So, mm, s- so
So when
for
will you share these slides? I mean, on which platform?
In a couple of hours, I will send the email.
Okay.
so on about making teams on Microsoft Teams. So we for the CRs, so we have to make a team just for our batch, right? And we'll be including the teaching assistant in our team when I make the team for my batch.
Yes, for tutorial
So
based.
yeah, so how do I get ID of my teaching assistant Because right now I just have the number that
You have the number and you have the name also. So if you search a name, let's say if you write, let's say I am one of the tutorial teacher, right? So if you, maybe my name, I don't know my name is there or not. Let us say this Hariom Sharma, he is assigned as 5. So if you search Hariom Sharma in MS Team, you may say more than one Hariom Sharma, but then you have to see a PhD student is in mathematics.
okay, so actually I did search, but the for our batch S7 there's only Shivam, there's no last name, and there are many Shivam, so that's
So
why.
you look at who is involved in PhD mathematics.
Okay, PhD mathematics division.
Yes.
Okay, thank you, sir, thank you,
Okay,
sir.
and if you are still or not able to find him, then you can call him.
Okay, sir. Okay, thank you so
Okay.
much, sir.
Okay.
One last doubt.
Yes.
Sir, I understood all these operations, but my doubt is that why do we do it? Why is this applicable? Like, for example, when you say elementary algebra, like 1 plus 1 is 2.
Hmm.
So that is like really common sense that when you add two things, 1 and 1, they make 2. But here in matrix, I cannot comprehend the transformation things here. Like, why do we do these transformations? What is the significance behind this?
So all these things they are very much practical things. For example, if you learn, let's say, if you want to study something which has two things in common. Let's say I have marks of students in mathematics as well as in English.